Okay, so let's review a little bit of what we did yesterday. So I saved my notes from yesterday. We talked about completing, we didn't talk about completing square. We talked about solving, I lost my pen. Solving quadratic equations. And before we could do that, we had to do some factoring. We don't need to talk much about factoring. But what we said we're going to do is we're going to be looking at this and this kind of as a majority. So I need to do a completing the square problem again. So let me throw a page in here. And let's complete the square. Does anybody have a favorite one they want me to complete? Where you maybe, I don't even know if I've given you any to do yet.
Well, you should.
I'm just going to grab one. Let's do an easy one first. This is number 10 on the homework. This is number 10. I don't know if I'm going to assign this or not, but this is 10. Let's walk through how to complete the square again. We said we have to have a coefficient of 1. We have to have a coefficient of 1. So we have y squared plus 10y. We have the coefficient. And what I said is it's a good idea to leave a space in there. Move the constant to the other side. So we complete the square by going y plus. If this is plus, this is plus. This will always be half of that coefficient of the linear term. So half of 10 is 5. So if that's 5, if you do binomial expansion, FOIL, you're going to end up with plus 25 that we just added to the left side. 5 times 5. When you do y plus 5 times y plus 5. If you do it to the left side, you better do it to the right side so everything stays in balance. So now I have negative 10 on the right side. When I solve this, to undo squaring, we square roots. We have y plus 5 equals plus or minus the square root of negative 10. That tells me I'm not going to get a real answer. I'm going to get an imaginary answer. My last step is negative 5 plus or minus the square root of negative 10. Some people I would hope you could rewrite this as negative 5 plus or minus I times the square root of 10. Those are imaginary answers. So in other words, you couldn't factor this one even if you tried. You couldn't come up with two numbers you could multiply to get 35 and add to get 10. It's impossible. You get an imaginary answer. Next week when we learn about graphing these things, we'll talk about where this parabola would actually cross the x-axis, but right now we're not worried about it. Let's do one more where the number isn't 1. When I say 1, this one right here, that coefficient, the leading coefficient is 1. You don't have to divide by anything. Let's see if I can find a tougher one. Let's just make something up. Let's just make up something like 3x squared plus 21x minus, I don't want to get carried away here. Let's make this one decent. 12 equals 0. So your first step is to divide everything by 3. And I think at the same time we're going to move the constant to the other side. So I'll have x squared plus 7x. Leave a space. That'll be 4 because it's 12 divided by 3. Could make it a little harder and throw some fractions, but I don't want to do that. So this is now x plus because this is plus. If this would be a minus, this would be a minus. But no matter what, when you fill in the hole, this will always be plus because you're either squaring a negative number or squaring a positive number. So half of 7, I'm going to write it as a fraction, 7 over 2. So in the hole, what we got to fill in is 49 over 4. So over here we have to add on 49 over 4 because you've got to do the same to the left and the right, the same thing. So this is 16 over 4, getting a common denominator. I think it's quicker than using your calculator personally, unless the numbers are bad. 16 over 4 and 49 over 4 would be what? 65 over 4. We're almost done. We have to undo squaring by square rooting. So I have x plus 7/2 equals plus or minus. That'll be the square root of 65 over the square root of 4. And the square root of 4 is 2. This should make you smile right here because what you have right here common denominator, that's good. You have a common denominator, so you have x is going to be, this is all over 2. This will be a negative 7 plus or minus the square root of 65. From there, we went to the quadratic formula. In the quadratic formula, I'm just going to walk through the steps on it. I'll find it. We developed the quadratic formula. So we said that the numbers in front, these are numbers, A, B, and C are numbers, and A is not 0. So if I first look at, here's my numbers, I divide everything by A, and then what happens when I divide it by A, I have negative C over A on this side. To figure out what goes up here, we have to do half of B over A, and half of B over A is B over 2A. So when you square that, you get B squared over 4A squared. You need to add that also to the other side. And that's the hard part, I guess, is getting a common denominator to come up with this. We undo squaring by square rooting. So I change the order on the top to B squared minus 4AC. And then the square root of 4A squared is 2A. Move the B to the other side because we have a common denominator here. And this is the quadratic formula. I didn't get the feeling yesterday that you haven't used that. But it surprised me just a little bit. To use this, I think it's important to understand the steps to get there. So that there's some logic, not just randomly throwing it out there. Okay? That to me is what you like about math, is you can kind of show why you have something, not just, here, memorize this, memorize this, memorize this, memorize this. All right, and we use the quadratic formula to solve. Do I need to do any more with the quadratic formula, you guys? I knew we needed to review completing the square. So I assume I'm supposed to do the quadratic formula on this problem. So let's review the quadratic formula on this problem right here. The first thing I would want you to do is rewrite it so that it's in the order so you can determine your A, B, and C. So x equals, the way my brain works, if I see something, I kind of just memorize it. So what I like to do is I like to write things down, because if I see it, it's just in my head and I can get it. Some of you learn best by hearing it. Some of you, you make up a song to it. Some of you make up a dance to it. I don't know what some of you do, but somehow you got to memorize it. You got to know that's the quadratic formula. Know what your A, B, and C are. So I would then have 4 opposite of B, and B is negative 4. So opposite of B plus or minus square root B squared, that'll be 16 minus 4 times 2 times 7. And then again, this is all over. Some people make a mistake and all they do is they put the divide sign like that. No, everything on the top is divided by 2a, and 2a is 4. So I end up with 4 plus or minus square root 8 times 7 is 56. 56 and 16 is how much? 672 maybe? Correct me if I'm wrong. All over 4. We can simplify that. What nice number can you divide out of 36? What nice number is a factor of 30? Oh, I just said it. 72. A nice number that's a factor of 72 is 36. It goes in there twice. So I have 4 plus or minus the square root of 36 times 2 all over 4. So my final answer would be, well, let's not go final yet. 4 plus or minus the square root of 36 is 6. Roots of 2 all over 4. So now you look at this number, and this number, and what do they have in common? Because you're going to divide everything by 2. So if you divide everything by 2, you get 2 plus or minus 3 roots of 2 all over 2. If you didn't want to do it that way, you could have divided each one by 4. If I divided each one by 4, I would get 1 plus or minus 3 roots of 2 over 2. Now the divide sign is only that part. They're the same thing. And if you want to find the about, you can find the about. You're with me on that? Just some little simple mistakes that I've recognized that students make over the last 20 years. It's all divided by 2 here. Here, just part of it's divided by 2. Quadratic formula. We're good on that, huh? All right, let's move on. The discriminant. The discriminant is part of the quadratic formula. It's this part right here. It's the part that's underneath the square root symbol, that's called the discriminant. It tells you things about your roots. It tells you three things, in fact, about your roots. If b squared minus 4ac is positive, if b squared minus 4ac is negative, and if b squared minus 4ac is equal to 0. Those are the three things that can happen when you think about the discriminant. Let's start on the bottom. Let's start in the middle. The middle one's the easiest. If your discriminant is less than 0, we had one like that today. What did we say the answer was? The roots. It tells you about the roots. What does it tell you about the roots? So we're talking about the nature of the roots when I do it in this color. If it is less than 0, your roots are not real. They're imaginary. Your roots are imaginary. They're complex, whatever word you want to use. They are complex. They'd have an I. If it equals 0, so if you have something like 6 plus or minus the square root of 0 over 12, what's your answer? In other words, you get one answer, one root, because that would be 1/2. Plus or minus 0 is 0. Doesn't matter if you add it or subtract it, it is 0. So you get one answer if your discriminant is equal to 0. And on top, if your discriminant is positive, well then you get 2 real roots. It also does tell you if it's nice. If it's nice, what do I mean by nice? What's a nice number? That's just because Brady's wearing it. It's not that nice. 3 isn't nice. No offense to Brady. 4 is nice. 9 is nice. 16 is nice. Perfect squares are nice. If it's a nice number, that just tells you that you could factor it. That's all. And you're going to get rational roots. You would get a rational root versus if it's not nice, you'd get an irrational root, like the square root of 5. But if it's nice, you get a rational root, which tells you that you could factor it. But ultimately, it tells us that we get 2 real roots. Okay? Any questions on that? Let's move on. There's 2 things I still have to get to. And that's this. This is one of the type of problems. I would definitely get this in my notes. The 2 topics I'm going to cover right now, because we're trying to solve quadratic equations, but there's 2 things that can happen. Sometimes you gain a root when you solve, and sometimes you lose a root. We need to distinguish the 2 and be aware of when it happens. So I'm going to try to show you the different types of problems where it happens. This one right here, depending on how you solve it, there's 2 choices. You could either multiply it out, and I guess if I were inclined, I would probably multiply this out if it were me working on this. So I would say 4x squared minus 4x equals 3 times x squared minus 2x plus 1, and I would go do the work. If you do it that way, you don't have to worry about either of those. No worries, no checks. But some of you, and it's logical to do this, because you have a factor equals a factor over here, you could divide this side by x minus 1, and you can divide this side by x minus 1. That's logical. If you do it that way, you are assuming, and we all know what happens when you assume, so please be careful when you assume. If you don't know what happens, ask Levi, because he seems to know. When you assume, you are assuming right now that x can't be 1. How come? And a lot of us don't write it down, we just assume it. X can't be 1 because you get a 0 in your denominator. You can't have a 0 in your denominator. So be careful when you assume, because if you do that, you're going to get 4x equals 3 times x minus 1. You're going to get 4x equals 3x minus 3. You're going to get x equals a negative 3. And you're going to think there's one answer. You just lost a root when you did that. There is more than one answer. If you look down here, you see squared. That would tell us that there's probably going to be two answers. They might both be real, they might both be imaginary, or you might get one real root, and it would be what we call a double root. But in this case, we lost a root. We assumed that it can't be 1. So then you have to say, what if x equals 1? If you plug in 1 up here, what do you get? If you plug it in right here, you get 1 minus 1, which is 0. 0 times who cares is 0. On the right side, you get 1 minus 1, which is 0. 0 squared times who cares is 0. Does it work? Yes. So it's a solution. So you have two solutions, and the two solutions are x equals 1, x equals negative 3. So if you ever divide by a factor, be careful. That's all I'm telling you on this problem. If you do what I did down here in lavender, you wouldn't have that problem. You would be able to get it done, you would factor it, and it would get two answers. But if you divide, you always risk the chance of losing a root. That's all I'm telling you about. That's one example of losing a root. Let's do another example. You have a bunch of fractions. I'll give you a second to write it down. If you're going to solve this one, a method of solving this would be clearing the equation of fractions. That's my words that I like to use. And that's what my math teacher did when I was your age, so I use the same words. Clear the equation of fractions. I'm going to first want you to recognize that this is a difference of 2 squares. That's a difference of 2 squares. You know that, or you should know that if we're in pre-calculus. If not, I'll review it, just like completing the square. If we need more, we'll go over it, but we should know that. We're going to clear the equation of fractions. That means we're going to multiply every term by x minus 2, x plus 2. So when I multiply the first term, this is a term. Terms are separated by plus signs and minus signs, so there's a plus sign. So this is a term, this is a term, this is a term. Whereas back on that problem we just did, we had one term on the left, we had one term on the right, because they weren't separated by any plus or minus signs. So I'm going to multiply everything by x minus 2, x plus 2. So this would cross this out, this denominator. I don't usually write it down by every single one, but I'm going to for you today. So this crosses out with this one. So I have x plus 2 times x plus 2. This one, I'm going to use this instead. This crosses out with this one. So now I'm going to have x minus 2 times x minus 2. And on the right side, this one crosses out with this one, and this one crosses this one out. They divide to 1. So what are you left with on the right side? Left with 8 minus 4x. What?
I have no idea what you just did there.
You've never worked with fractions before?
Oh, no, I have, but you went really fast for me.
I gotta talk slower. Gotta talk louder. Is that usually what we do when people don't understand? We talk louder and slower. You ever seen people talk to old people? When I'm old, I'm kind of old, but don't, yeah. All right, let's do it again. Let's do it again. Can somebody give me the original problem?
X plus 2 over x minus 2 plus x minus 2 over x plus 2 equals 8 minus 4x over x squared minus 4.
Okay. Okay, so we recognize this as a difference of 2 squares. If you don't, you need a lot of extra help. That's x minus 2 times x plus 2. So I look and see what is the what's the word we use? Greatest common factor. What do they all go into? So you're looking at the factor x minus 2, x plus 2, and x plus 2, x minus 2. And what do they all go into? You should know about greatest common factor. You also should know about least common multiple. They all, I guess this would be the least common multiple, wouldn't it? What do they all go into? They all go into x minus 2 times x plus 2. So we are clearing the equation of fractions. I'm going to multiply everything by that. That's legal. It's legal to multiply the left side by the x minus 2, x plus 2, the right side by x minus 2, x plus 2. The reason on the left side I multiply it by both is because there are two terms. You have to distribute it. So instead of me writing distributive property, I'm going to write it by each one. So when we multiply, I want you to know that this factor divides with that factor because they're the same thing. So now you are left with x plus 2 times x plus 2. On the middle term, when you multiply, that crosses out x plus 2. So we are left with x minus 2 times x minus 2. In the last term on the right, they both are going to divide to 1. Again, I don't like to use the word cancel, but that's really kind of what they're doing. They are dividing to 1. So you are left with, on the right side, 8 minus 4x. So we have now cleared the equation of fractions. So what we have in orange right here is the exact same thing as what we have in blue. But the one in orange is easier to solve. That's why we clear the equation of fractions. Now I'm going to do FOIL. So that's x squared plus 4x plus 4. If you need to draw in the arrows and do that, that's fine. But I just hope we can speed things up a little bit and do FOIL in our head. Your calculator won't help you. When we do FOIL on this one, we're going to get x squared minus 4x plus 4. And on the right side, I have 8 minus 4x. Now we look for like terms. Like terms on the left gives me 2x squared plus 8 because these two are opposites, so they add to 0. On the right side, I still have 8 minus 4x. I'm going to move the 4x to the other side, and I'll have 2x squared plus 4x. And if I move this 8 to the other side, I'm going to get 0. They're going to cancel each other out. I suppose they're going to add to 0. I'm going to factor that. So I'm going to take out 2x. And I'm going to get x plus 2. So this tells me my solutions are 0. This one right here tells me 0. This factor right here tells me negative 2. Okay on that? I know I have a tendency to go fast. I apologize. You need to call me on it. That's my nature. Okay? Because there's so much good stuff I want to teach you. Do they both work? You have to test it. You have to check your answers. What I would have really loved is way back at the beginning, it's a good idea always to start and tell yourself what you can't have. So you look at your original problem in blue, what can't you have? This right here says you can't have 2. This says you can't have negative 2. This says you can't have 2. This says you can't have negative 2. You can't have plus or minus 2 on this problem. We got negative 2, so you have to throw it away. You cross it out. So back to what happened. We talked about losing roots and gaining roots. On that particular problem, or this one we just got done doing, we gained a root. You got to check your answers in the original to make sure you didn't gain a root, which we did. So all you do is just cross it out and say, I can't use that one. The only solution is 0. So whenever you clear your equation of fractions, be aware that you might gain a root. You don't always gain a root, but you might. Likewise, when you are dividing, make sure you don't lose a root. There's one last problem I have to talk about that deals with these two. The type of problem is when you solve a square root. This is the last one I have to go through, solving a square root. How do you undo a problem like this? How do we begin to solve a problem that has a square root? Provided that the square root is isolated, provided that the square root is by itself, you simply square that side. Because we've already talked about this, the square root of star plus triangle, if I square that, what do you get? You get star plus triangle. So on this problem, when you square both sides, I'm going to have 3z plus 6. But on the right side, it's a little bit harder. I still hope you can do FOIL in your head, but if you can't, it's not a knock against you. Then you just rewrite it. And you do FOIL. So you're going to have 4z squared. Outside is 2z, inside is 2z, so that's 4z plus 1. I like my quadratic term, I like it positive, so I'm going to push everything to the right. I like my quadratic coefficient positive, so I'll have 4z squared plus 1z minus 5 equals 0. Because this is a book problem, I have a hunch that I can factor it. If I would just make up a problem, I probably could not factor it. But because it's book, I'm thinking I can factor. I'm leaning towards 4z and z right now, and I'm leaning towards 5 and 1 as I look at it. Does that make sense when you factor? I get the 4z squared. I want 1z in the middle to be positive, so I'm going to make the 5z positive, and I'm going to make the 4z negative. So what does this say my two answers are for z? And yes, these problems require more than one piece of line on your paper. Paper's cheap. Use it. Don't try to, and work down. Work down. I hope that you've been taught that through the night. I'm not going to change you now, I suppose, but I can't stand trying to read somebody's paper if they work left to right like a book. Work down. It's easy to see your steps.
1 and negative 5.
1 is a solution and negative 5/4 is a solution. Whenever you square square roots, always check your answers because you might gain a root. Check it in the original. So I'm going to check it right here and right here. We'll check 1 first. 3 times 1, 3 plus 6 is 9. The square root of 9, of course, is 3. Over here, 2 times 1, 2. 2 plus 1 is 3. Square root of 9 equals 3. Right on. We know that one works. We checked it. Negative 5/4. Need a little help. 3 times negative 5/4, negative 15/4, plus 6. And 6 is 24/4. So that's 9/4. So I'm going to do the square root of 9/4, which is nice. What's the square root of 9/4? 3/2. Now we got to check it on the right side and see what we get. 2 times negative 5/4 is negative 2/2, or 5/2, 2.5, plus 1. Negative 5/2 plus 1, negative 2.5 plus 1 is negative 3/2. What do you know about negative 3/2 and positive 3/2? They're not the same, are they? They're not equal, so you gained a root, throw it away. Doesn't make sense why it would work when you square it, though. if that's what you had, if you square this side and you square this side, is it clear that they're the same thing? It works when you square it. So when you square things like we did way back here at the beginning, we gained a root. So be careful when you square roots, you might gain a root, check them. Sometimes you don't, sometimes they both work. But sometimes they don't both work, and make sure you cross it out. Okay? Quadratics. All right, what we're gonna work on is multiples of 3. I don't know if your teachers have given you assignments like this before, but 3 through 30 multiples of 3. That means 3, 6, 9, 12, 15, 18, etc. And then I added on another 5 problems. 31, 33, 35, 38. In 41, I've starred, which tells me we're going to say that one's extra credit. Challenge, way for some of you to gain some homework points that maybe you've missed along the way. So 41, I'll call that one extra credit. I will give you a hint. You're going to need to square something twice at 2 different points in the problem. If you still aren't sure how to complete the square, or you're not sure how to clear an equation of fractions, please talk to me. Kind of getting to be a regular business. I've got regular office hours before school, and I'm getting regular people coming in. Please feel free to come in anytime you want before school. We'll go through anything you'd like. That is the part of my job that I really enjoy, because I think when you sit down sometimes and you do it individually, it clicks really fast. Here there's distractions. Some of you handle those distractions better than others of you.